All right, so good evening once again, everyone. So in this live session, we are going to start with week 6 in particular. However, we'll briefly go through the concepts discussed in week 5 also, just as a recap, so that we are on the same page, and I'll be discussing week 6 concepts. So I was hoping if I could at least start with some parts of the week 7 also, right? But if time permits, I'll see if I can discuss that as well. Okay, so in week 5, we start with logic based testing, right? So up until week 4, we had seen graph models of the underlying program. So there's this program that you need to test, and then we convert that into a CFG basically. And on that CFG, we are running various algorithms that are going to do the coverage criteria, right? And the coverage criteria also are defined in terms of the graph that is there, control flow graph. So now moving forward in week 5, we will see something different actually. So this one is in particular tied to the predicates and the conditions that are there in your program, right? So we are interested in testing those predicates that are there, right? So we have to employ a different kind of model here, or rather a testing technique which is different from what we've seen so far. Okay. So week 5 and 6, both of these weeks mostly deal with logic based coverage criteria. And then from week 7 onwards, we are going to see something different, which is symbolic testing. Okay. So I'll start with that. I think some of the logic basics we've been discussing it. I think in the previous terms also we have discussed it. So in case you need detailed discussion on basics of logic and so on, you might as well go through the previous recording and understand that. So in this session, what I can do is I can possibly quickly go over these concepts and then start with the coverage criteria. So in particular, I am going to discuss general active class coverage, and restricted active class coverage and correlated active class coverage as well. So active class coverage is basically discussed in week 5, and in week 6 we discussed inactive class coverage. So both of these coverage criteria, active and inactive, actually pertain to logic based testing technique actually. All right. So I'll start with logic coverage criteria actually, and wherever needed, I might as well go back and discuss some portions from logic basics. Also, I presume that it'll be okay. So let us start with the criteria that is there, because I think there's some things to cover actually that'll take time. So uh, you know, so I would rather skip the basics part. Okay. So this is some sort of a recap that is there in predicate and clauses. Okay, so you have to understand that it is basically a condition that is given in the if your if loop, okay, or the if statement that is there. So inside of that you give a predicate, okay, and it evaluates to a boolean value always. I mean, most of you would know that, right? So it is either going to be true, a predicate inside of an if condition, or false. All right. So that is the only two possible values that a predicate could take at runtime. Right. So for example, now this entire thing might be called a predicate. So you have, and then the constituents of a predicate, and there's a definition of the clause also, is basically a clause, right? So these parts that you see inside of a predicate are basically clauses. So in other words, we can say that a predicate is made up of various clauses that are there. Okay, and the definition of clause goes like this. So it says a clause is a predicate, is also a predicate that is also going to be evaluated to a boolean value, but it says it does not contain any logical operator by itself. Okay, so it is as if you say, for example, so in this particular predicate, you have or, right? So this or connective is there. So this downward arrow, I mean, in some sense, is basically your or operator. And similarly, you have and not and so on. All these operators are there. So when you keep breaking this down, a predicate, as soon as you are left with something which does not contain any logical predicate, logical operator rather, then it will be called a clause. So it is like in some sense the smallest unit of a predicate, right? So you've got this, right? And then again, well, I should not say smallest unit, because the smallest unit could as well be the atomic variable that is there. But you understand, right? So as once we get something which is not having any logical operator in it, that is basically your clause. Okay, so for example, this part is x greater than y is one clause. C might be a constant or something boolean variable that could take on any value, again true or false, right? So it could be also be there. And then f of z is also a function that is going to return a Boolean constant, a constant that is true or false again. Right? Think of it like maybe a method to check for primality and so on. Then if the number is prime, then it is going to return true, otherwise false. So in principle, what value you could get here is actually confined to either being true or false. So that is the idea in a predicate. Okay, so this I think is enough in terms of the basics that we need. And then regarding the operators and so on, as we move along, I think I'll be describing them as well as if no, as and when necessary. So that should be okay. Yeah. So some notations that we have to be careful about, in particular for this coverage criteria that are there. So it says P, we denote it as the set of predicates. Why? Because again, remember, we are trying to model a program or maybe a part thereof. It could as well be a method, right? But inside of a method also, you could have multiple predicates, multiple if conditions. And all of those if conditions will have their own predicates, right? So therefore, when we say we are going to do RACC or say CSSC or GSSC, anything on the method that is given, it might be that you've been given a source code and it is asked that what are the, what are the test requirements, for example, for GACC for this particular method. Okay. So in that case, we consider all predicates and do it for all of them. Okay. So the set of test requirements will contain the requirements for all the predicates that are there. Therefore, we call it P, and therefore that is a set of predicates. But in general, you see, most of the questions we will be dealing with only one predicate, at most, because otherwise, if we have too many predicates, then it might become time consuming to deal with them. But then again, the general idea is that when we say we're going to do on some method these coverage criteria, logic based coverage criteria, that includes all predicates that are there. Therefore we say P is having all predicates. Now C is another set which says all clauses therein. Okay, so you have multiple predicates in P, and then for all those predicates are made up of multiple clauses in them, right? So then C is basically set of all clauses in all predicates. That's what you have. And the C sub P, C small p that is there, is actually denoting, the clauses in a particular predicate. So then we have P, which is small p belonging to capital P, one of the predicates I take from there. Then all the clauses that are pertaining to that particular predicate will be denoted as C sub P or C small p that is there. So that is what it says, for each predicate P, let CP be the clauses in P. So that's okay. So therefore it says CP is basically set such that C is there, which is actually belonging to this particular predicate. And then what happens is that when you take union of all such clauses for all predicates, right? So then you get this C, the capital C, which is the set of all clauses in the method, irrespective of which predicate we are talking about. Okay, so that's what happens. All right. And in case there's any confusion at any point, please feel free to unmute and ask questions also. It's fine. Okay, so we are going to start with the very first and perhaps the most naive coverage criteria in logic-based testing, that is predicate coverage. Okay, and again we are coming back to the terminology that we've been using in software testing. So this is TR, test requirement. Okay, when we say we are going to do some sort of a coverage criteria on anything, be it graph model or logic-based testing, whatever, then we'll have a set of test requirements that we need to cover for. Okay, so in this case, for predicate coverage, to achieve predicate coverage, it says there are two requirements for each predicate that are there. Okay, so for the sake of simplicity, I will assume that there's only one predicate. Okay, because most of the time we're dealing with one of the predicates only. But in general, you can extend it to multiple predicates, and for each predicate, you do this coverage. Okay, but yeah, so let's assume the case wherein there's only one predicate. So you're going to do predicate coverage on that predicate, which is small p. So two requirements are there. Two requirements says that p must evaluate to true once, meaning you should cover for the case when it is true once, and you should also cover for the case when it is false once. Now if I were to connect the dots, you might be able to realize that if we do predicate coverage, right, this is akin to doing edge coverage on a CFG, because remember, edges are basically denoting the conditions that are there, right, on the branches. So in if that is actually being being described based on the predicate that is there, no, based on the if condition. So if predicate is there which evaluates to true, then I'm going to follow one branch. If it evaluates to false, then I'm going to follow another branch. So if I do predicate coverage, then in terms of logic, from the perspective of logic coverage criteria, then that is actually equivalent to doing branch or rather edge coverage on the graph model, meaning on the CFG. because that's what it says. Okay, so considering this predicate, this is a general enough notation. So there are three things that are there, like three clauses rather. Two tests will be sufficient, right? So I only need two things, right? One case wherein my predicate evaluates to true, the other case when it evaluates to false. And remember, this is or, right? So x greater than y or c or f of z. Okay. So what happens with or is that if any one of the clauses become true, the entire predicate will become true. Okay. So if I want to make this predicate true, what I can do then in that case, I can select x and y such that x greater than y is satisfied. So as soon as this is satisfied, this will become true. Is if this becomes true, then the entire predicate will become true. I hope my audio is clear enough. Quick check. I just wanted to.
Yes, it's clear.
Thank you so much. Yeah, sometimes it happens that the audio is not going through. Okay, fine. So that's the idea. Okay, so one way of making this predicate true. What is the other way of making this predicate true? Maybe x and y you don't select such that this is satisfied. Let's say x is equal to y. So then in this case it'll be false. That's fine. But again you have a c here. No, maybe c is a constant. So maybe you can set c to true. If it set c to true, also this is fine, right? Because as soon as c becomes true, again the entire predicate will become true. So one case will be covered, right? One case. Similarly, for f of z also you can do the same thing. If f of c becomes true, the other true or false, then in that case also it is true. And if all of them are true, also it is true, right? Because or, right? The you know typical nature of or, yeah. Any clause becomes true, entire thing becomes true. Okay. Now, two things I need to do: make it true once and false once to satisfy predicate coverage. How do I do that? So in this case, it says I'm going to select this. Okay, so 5 greater than 3. So again, it will become true. Maybe I can select c is equal to true. One nuance that I'd like to point out here is that in the case of or, such predicates, no or is there, right, in between. This is called a disjunction. Um, yeah, it's called a disjunction or operator. So in the case of or, what happens is the first thing becomes true, then you don't go and check the other ones. Okay. If only the first one becomes false, then you go to the next one and see whether this is true or not. Right? If this becomes also false, then you go to the next one and check whether this is false or true. If this is also false, then the entire thing is basically false because none of the clauses are becoming true. If that happens, in the case of or, make everything false. So therefore, the entire predicate will become false. So in this case, what we are doing is we are selecting 5 and 3 for x and y. Then the predicate will become true now itself. We need not even go to check c and f of z, regardless of the values. These values this will be evaluated to true. So that's fine. One case we've covered. So maybe we can have one test case, which is this, to make it true. How do I make it false then? But the thing with or is that we have to make all of them false to make the entire predicate false, right? Again. So then we are selecting this 1 and 4. So 1 is not greater than 4, therefore this is false. C we have set to false. So this is a constant, this is false also. F of z also we are assuming that it returns false. We are setting it to false. Then since all of them are false, the entire predicate will evaluate to false. Once you're clear with this idea, I think most of the things that are going to follow will be easy to understand also. Okay. So this was one of the basic coverage criteria. You have a predicate, you want to make it true ones and false ones. Simple enough, I believe. Okay. All right. And this part I think I mentioned already, right? So overlap is that basically all the branches, if you do predicate coverage, all the branches will be covered, hence satisfying edge coverage on the CFG also. Okay. So this was predicate. No, we are talking about the entire thing. Right. We are saying that entire predicate true, entire predicate is false, and I'm done with that. But it does not exercise the individual clauses, right? Now again, let me take a step back and just to give a little bit of background as to why we want to do this. One thing is just predicate, right? But it might happen that certain conditions, certain edge cases might happen, right? This is a simple enough condition, so you might not be able to realize, but in most of the complex situations, a lot of conditions are there, right? Lots of clauses are there, very complex situation, predicate is there. Now in that case, there might be edge cases, no, certain edge cases that might arise. Let's say you have a predicate, let's say maybe 10 clauses are there, and so many possibilities are there. If something turns out to be in a particular combination, maybe you hit an error. It might happen, right? We don't know in advance. This is general enough. So in that case, what we are trying to say is that we'll rather exercise every clause also, not only the predicate. It might be that some clauses may have a problematic behavior, right? When they become false in a particular situation, something goes wrong, you hit an error, some failure occurs, and so on. That can happen. So the idea is to test as thoroughly as possible, and therefore we are saying that we'll exercise the clauses individually also. Okay. So then we see clause coverage. Now again, so predicate coverage, what we said, so predicate evaluates to true ones and false ones. In clause coverage, what we are saying, We're saying the same thing, but this time we're not taking it from P, we're taking it from C. Right? That's all clauses that are there, including from different predicates that you have. You're going to exercise all clauses, meaning you have to make every clause true ones and false ones. That is your TR for clause coverage. Okay, so again, the previous example, previous predicate, what we have to do. So for example, okay, so I have to exercise all three, right? So first thing is that x greater than y, I need the true case for this one. So I'll select something, right? So 5, 3 maybe. So this is a true case for the first clause. That's okay. And now I need to make it false also. So maybe I'll select this one, 5 and 6. So this becomes true and false. That's done. We'll go to next one now. C. So C has to be true also, false also, right? So individually. And then I go to f of z. F of z is true. F of z is false. Now clause coverage is done, right? So hence 6 requirements you have, because again it's quite easy to understand, right? Three clauses you have, each clause is having two requirements, right? So true and false, therefore 6 in total. Okay, this is what clause coverage, and we are trying to notice a pattern we are trying to build up. We are trying to go in a iterative manner, and trying to come up with newer and newer coverage criteria for logic based testing. That'll make it more you know robust and useful. Okay, so the basic one was just predicate, and then we said no, we are going to exercise every clause. Then there is clause coverage, and then we are moving forward also. So one slight detour here, we are comparing clause coverage and predicate coverage. So one thing is to note that is very important is that if you only do clause coverage, then it does not subsume predicate coverage. Okay, so that is one thing. So if you are exercising individual clauses like this, so all these requirements are there, 6 requirements. So if I do all these requirements here, maybe it might be that clause coverage, rather uh, predicate coverage is not achieved. Okay, so actually it does not subsume. Like for example, in this case, you see what happens. So P is equal to A or B. A or B are clauses, right? So A is a clause, B is a clause. So it says the clauses A and B, there are 4 test inputs, right? So all combinations. This is called a truth table. You might know this. Okay, so we try out every possibility. So what happens when A is true, B is true? A or B will be true, of course. True, false, A or B again true because A is true, so the whole thing becomes true. False, true is also true, so that's fine. Only when both are false, it is false, so that's fine. But you see, what happens with these 2 and 3, rows 2 and 3, if we select 2 and 3 as our test set, as our test requirement set, right? In that case, what happens? Clause coverage will be achieved, right? Because what I said again, for every clause, you have to make sure it becomes true ones and false ones. So isn't it happening in 2 and 3? So for 2 also, you have A becoming true, and 3, you have A as false. So true, false is achieved for A. Right. For B also, you have two, and B is false. In 3, B is true, right? So false and true, B. So clause coverage is achieved for B also. But you see, for both these cases, 2 and 3, rows 2 and 3, A or B remains true, right? It does not go to false, right? So we have shown one example wherein it happens that, and there are other examples also. In this case, it happens that even though clause coverage is achieved for both the clauses that are there in this particular predicate, however, predicate coverage is not achieved. Therefore, we say clause coverage in general does not subsume predicate coverage. Okay, please keep this in mind. All right. So yeah, the same reasoning is given here. Fine. I hope it is understandable. So then we said, now, okay, let us try something more. Maybe it's more basic, but it says it is combinatorial coverage. Okay, so my name might suggest something. It says for every predicate P, small p belonging to capital P, TR contains test requirements for the clauses in CP. That is, the all clauses belonging to that particular predicate to evaluate to each possible combination of truth values. Now you might guess the problem with this one, but that's what it says. So we saw that if we only do clause coverage, then predicate coverage is not subsumed. If we only do predicate coverage, the individual clauses are not exercised. It is not robust enough in that sense, right? So then we said, okay, let's try out something more trivial. This is combinatorial. So I'm just saying that every possible combination you try it out, okay, for all predicates. So for example, I have this predicate A or B, then I'm going to try out 1, 2, 3, as well as 4, all combinations, right? Now the problem with this particular approach, combinatorial coverage, is that as the number of clauses grow, okay, the combinations will grow exponentially. You might know that the total number of possibilities will become 2 power n, where n is basically your number of clauses. In this case, you see there are 2 clauses, right? So 4 combinations are there. 2 power 4, 2 power 2 is 4, right? So therefore, as the number of clauses grow, it becomes very difficult. So even for, let's say, 100 clauses, it becomes somewhat infeasible to cover that, right? And it's a waste of basically compute resources also. It'll take a lot of time to just compute the truth table for it because exponential possibilities are there. So therefore, it is not feasible. Yeah, same thing it's mentioned here. Predicate p n clauses 2 power n possible assignments of truth value is not feasible many times. Correct. And it says, in fact, we might not need it, right? Why do we need to? I mean, why do we need to check for every combination? I mean, it does not make sense. Very trivial, right? We are only interested in certain cases wherein we are trying to capture the effect of each clause. What did we say again? The predicate coverage was talking just about the entire thing. It was not testing, so to speak, each clause, right? But if we do each clause, meaning clause coverage, then predicate itself is not achieved, right? Predicate coverage is not satisfied in that case. So then we need something else then. And then combinatorial is infeasible. So we are trying to do something which is kind of balancing between this trade-off. So uh, we still want to be able to capture the effect of each clause while doing this within a reasonable number of tests. That is not exponential, okay? Because exponential, is many times not feasible beyond a certain number, right? So that's the idea. Hence comes the idea of determination. Okay, why are we going this way again? Because we saw that CC, that is clause coverage, and predicate coverage have their own shortcomings, and we are trying to alleviate those. So therefore, we are trying to look for something more comprehensive, so to speak. Okay. All right. So it says sometimes the truth. So before going there, before going to what active class coverage is, basically, which is the main topic of the discussion for week 5. In fact, for week 6, we just go from active to inactive. So once you understand determination and activeness and where does that come from, it will be very easy for you to understand, inactive as well, because both of these things are basically related to each other. So it says sometimes the truth values of certain clauses in predicate makes the other clauses non-influential. Okay, so again, remember we are trying to capture the effect. That's what it said. No? I mean, how is that particular clause affecting the outcome of the predicate? Some sense of influence is there. Okay, so for example, I want to see how A affects P, or how A affects the value of P. Similarly, how B affects P, right, and so on. So that's what we want to check for, right? So it says in this particular case, what happens is that if we don't determine, we'll come to what determination is. So for example, if we take A or B, quite simple, right? So if A becomes true, assuming, then the value of P is going to be true, right? Because as soon as A becomes true, P is true. That's it. We don't need not check for B even, right? So now B is non-influential then. If A is true in this particular case, B's value will not have any say on the value of the outcome of the predicate, right? B, you can set B to true or you can set B to false, but as soon as A is true, the predicate becomes true and it is not going to change at all. So B becomes non-influential on that, in that way. Similarly, if A is false, then B, if A becomes false, then B's value will basically determine what P is going to be. And one thing before even going there, I just try to highlight is that please note that determination in this case, the way we are using this term, actually does not mean that it will change the value. Okay. It says if A is false, then B completely determines P, in the sense that truth falsity of B influences the truth falsity of P. But it might sound like we are saying that whatever B becomes, P will become that. So if B is true, P is true. If B is false, P is false. Or even if B is true, P might be false. So there's some sort of a correlation. Okay. But note that determination itself does not mean correlation. Okay. So be careful with that. We'll describe it moving forward. Also, it's just that we are saying that it can have an effect. Okay. When I set A to true, it is the other way around, right? When I set A to true, B is completely non-influential. Regardless of whatever value it has, it cannot affect P at all when A becomes true, right? On the other hand, when A is false, what we are saying then is that in this case, it happens that B is actually affecting it. But what we are saying is that it might have an effect. Like it has a possible influence on the predicate. It might or might not change. So therefore, correlation comes in the picture. Okay, so we'll come to discuss that as well. So that's what determination is that when you say something determines the predicate, it means that it has a power to change. Maybe it can change. On the other hand, if I say it is not determining or non-influential, in that case, it cannot change at all. Okay. So it is not if it is determining, it will change, rather it can change. Okay, so this thing is something that we need to keep in mind. So therefore, I say always that determination is basically a prerequisite and not a sufficiency. It's not like it is necessary but not sufficient to change. It is necessary to influence, but it is not always the case that if it determines, it will change. Rather, it can change. Okay, so that is the distinction that needs to be there. Okay, so it says we would like to test each clause under circumstances where the clause determines the predicate. Makes sense, no? Because if I set A to true, then checking for in that case checking for B does not make any sense. You see, because I mean A is true, so P is already true, and B in that case is non-influential. Then what does it mean to check for B when A is already true? Right? It does not make any sense. So then we say we have this prerequisite saying that we're going to test each clause, meaning make it true once and false once, under circumstances where the clause is actually determining the predicate, meaning it has a possible say on the predicate. No? Otherwise, it does not make sense to do anything. Okay, so that's where the idea of activeness comes from. When we say active, what we say is basically that we are that particular predicate and is being determined by a particular clause that we are checking for. Okay, so this will become clear, I think, with the help of an example. So I'll go through that as well. Okay, so before moving ahead, I'll just like to take a quick pause and uh, yeah, if there are any questions, please ask. See, I think people are joining.
So, so can you explain the last slide, last part that you have said that if A is false, then we
Uh-huh.
have to see the part of B. And what does B recommend that B completely determines P in the sense of truth or falsity? What does this mean, sir?
So it says, okay, so I mean, in this particular example is not good enough to convey the difference between
Okay.
determining and actually changing. You might think that, okay, so think about it this way. Okay, we will think about it in the in the usual sense first, and then we'll come back to
Okay.
distinguishing the difference. So
Okay, sir.
let's say by determination it means it will actually change. Okay, which is not the case, but assume that that is the case. So let's see if A is true, then I mean, very clear to see that B cannot affect at
Yes,
all,
sir.
right?
Yes, sir.
Now, so then I say I need to make B active. I need to make B the determinant. I need to make B the major clause, active clause. Okay, so what can I do to make B active? One thing is I can set A to false. Now, if I say to false, set A to false rather, you see that B is actually changing. Now it is changing, right? So if B is true, because A is false, A is no longer in the picture. So then when B is true, P is true. When B is false, P is false. So in this case, it actually determines, completely determines. It influences, not only influences, rather it actually changes it, no? Actually changes the value. So
Okay, sir.
it
Yeah.
has, in some sense, complete control over that. So as soon as I set A to false, I'll say that B becomes active. And by symmetry, you might also understand that if I set B to false, then A becomes active or determinant. Okay, and the
Yes, sir.
part where I said that actually determination itself does not necessarily mean that the value of the predicate will change, rather it can change. So that for that we'll have to see a longer example which is involved to be able to understand the difference. Okay, just keep that in mind for the time being, that determination itself is not necessary that it will, in this case it is changing, no? And most of the small examples you will see that whenever you determine, whenever a clause becomes the determinant, it is actually going to change the value of P. Okay, the values need not match. It might as well be that it is the invert. So when B is false, P is true. When B is true, P is false. It might also happen, but it changes, no? It has a correlation. It might happen for small examples, but in general case, it is not the case. Okay, determination is again, it's necessary but not sufficient. Okay, so we will see that actually in this particular example, it's not very easy to convey that. In fact, it's not possible to convey that in this, because you make it active. As soon as you make it active, you see it is changing. No, so so
Yes,
okay,
sir. It's
so
clear right now. Okay.
all right, yeah, fine, fine. Okay, so a little bit of terminologies again that we have to understand. So now let's say what we said again, that we would like to test each clause under circumstances where the clause determines them. Meaning, see, under circumstances where the clause determines the predicate, what it means in other words is basically under the condition when it is active. Meaning, we would like to test each clause when it is active. I would not like to test a clause when it is inactive. Inactive clause coverage criteria again. Okay. So in inactive actually is the other way around. In inactive, we say we would like to test each clause under circumstances where the clause does not determine the predicate. That is for week 6. Okay. We'll come back there later. But for activeness, we say that we're going to test the clause when it is active. It makes sense, I mean, logically also, that only when it
Okay,
has
sir.
an influence you're going to check it. Okay, so now the clause that, again, because predicate is there, so lots of clauses are there, and each clause is going to take turns, right? And the conditions, the circumstances differ, right? So in this case it is easy to understand, but complex examples might be difficult to understand. That, okay, so I have this predicate, I want to make A active, so what can I do? All right, so I can make B false, so A becomes active, right? And then I test for A. However, I test, so that there comes test requirements and so on. Now I want to test for A, then I have to make B false. No, that differs. So if I want to make something active, the conditions under which something becomes active, some clause become active, differs across clauses. How A becomes true does not necessarily is the way B becomes true. No, for B to become active, rather, for B to become active, there are other conditions that you need to satisfy. For A to become active, there are other conditions. In this case, it's pure symmetry. So you understand that. Okay, so for B to become active, A needs to be false, and for A to become active, B needs to be false. I mean, this is somewhat similar, but it might as well happen that other. So we can consider each clause separately. Okay, that is the idea. So what we do, we are going to do ACC, active clause coverage. The first thing you will do, you figure out which clause you're taking turns, right? So let's say I say, because again, remember C, the capital C, right? So each clause you're going to do. So let's say I start with, because you have to start somewhere. I'm going to start with A. First thing I'm going to do is I have to make A active. Okay, I'm not talking about how to make it active yet, but whatever predicate I have and whatever clause I'm going to test for, I must make that clause active, at least in active clause coverage criteria. Okay, so I start with A. I have to make A active. How do I make A active? In this case, it turns out to by making B false. I mean, in this case, I'm just saying by seeing that there's a way, there's an algorithm by which you do that. I mean, rather not an algorithm. There's a, yeah, basically you can figure it out. It's a formula kind of, okay, by which you can understand how to make something active. So I start with that. I make it active. It's a general template for solving such questions. Okay, make it active, and then again cover for the test requirements. Go to the next. So this was for A, right? Go to the next clause. Figure out how the next clause will become active. Okay, so make it active, and that conditions are set, and then test for it. Cover for the test requirements. Go to the third clause. Maybe if there is C also, you go to C, make C active, test for it. Then I go to D, make D active, and so on. That's how you do it. Okay, so the general way of doing it. Okay, so that's what it means to say you test each clause under circumstances when the clause determines the predicate. In other words, under circumstances when the clause is actually active, when it is actually having an influence on the predicate, not the other way around. Okay. All right. So now I said that basically we're going in turns, right? So once I make A active, then I test for it. Then I go to B, I make B active and test for it. Then I go to C and so on. So when the clause in focus, in some sense, the clause under consideration at this moment, because we're doing it for all clauses, that's okay. But at one point in time, you're going to focus on one clause, right? You start with A, make it active, right? So the clause under consideration at a particular point is called the major clause. Okay, so this point you have to make sure you keep that in mind. Now, what happens in active clause coverage criteria is that the major clause has to be active before you test. Okay, you make major clause active and then test for it. What happens in ICC, inactive clause coverage? You make them, therefore another terminology. We could have as well said it as the active clause, right? But that's not the case. It's a general enough term. We're saying major, whatever is in focus. Okay, we are interested in that at this moment. So then we say major clause. So in active clause coverage, you have to make the major clause active, then test for it, then cover for the test requirements, whatever they are test requirements. And for inactive again, it will be called a major clause, but this time you have to make sure that the major clause is actually inactive because you are doing RICC, So that's the idea. And as soon as something is nominated to be the major clause, again, remember we are doing it in turns. Okay, so you start with A, then you go to B. So it is not that something is left out. You're doing for everything. Okay. So when something is the major clause, all other clauses except the major are called the minor clauses. So for example, I start with A. So I say A is my major clause at this moment. I want to make this active. That's okay. So as soon as I say that A is the major clause, then B and anything else that is there automatically become the minor clauses. Okay. This is the idea. When I say B is the major clause, then A and whatever is there is the minor clause. Okay, go on, please. Somebody wanted to ask something, I believe. Any questions?
No, sir. No, sir. It's
Okay, okay. Thanks, thanks. Okay, I assumed that there's a question. All right. So then that's what I said. Each clause in turn is treated as a major clause because you're taking turns. You're making everything the major active in turn. So first turn is A, make it major, make it active. I mean, there's nothing called making it the major clause. Rather, you nominate it to be the major. I mean, you select it. It is the currently selected clause in some sense, right? And then you make it the active clause for active clause coverage, and then you cover for it. So determination again, it's the same thing we mentioned about influence and so on, right? That's the idea. That is called determination, activeness. The term active comes from determination. If something is determining something, if the C is determining P, then we say C is active. If C is not determining P, then C is inactive. Okay. So determination is actually activeness, whether something is active or not. All right. So it says,
Excuse me, sir.
go on, please.
So like if we have like A, B, and C in the predicate, so
Uh-huh.
like are we going to test for all of them? Like what
Yeah.
is the major class?
Yes, of
Like P
course.
of A, P of B, P of C, right?
Indeed, yes, yes.
Okay.
So each class in turn is treated as a major class, right? That is what it says. And remember, I think I mentioned it, but just again, so for inactive, we say major has to become inactive. Inactive, what we say? Inactive class coverage, we say that the major has to become active before we test for it. In inactive class coverage, the major has to become inactive before we test for it. Okay, and the activeness and inactiveness actually basically the determination itself. So in the active case, C must determine P, major clause must determine P. In inactive, the major clause must not determine P. Okay, so that's the difference. Okay, so we'll think about what determination is and how to figure this out. Let's say it's given a major clause. You all understand what a major clause is now, because what is the currently focused, the currently selected clause. Okay, and this is going to happen in turn. So none of the clauses will be left out. Everything will become at some point the major clause, right? And the other ones will become minor automatically, one at a time. That's okay. So given a major clause ci in a predicate p, we say that C determines P if the minor clauses Cj belonging to again all the other clauses in that predicate, Cj's. So Ci is the major. So let's say A is the major, then B, C, D, whatever else is there will be Cj's, minor clauses. So how do we determine? This is the definition about determination itself. So it says I have to set my minor clauses. Okay, we are not talking about the major. I nominated the major. Now I'm going to select values, true and false values for my minor clauses such that, okay, again, there's slight ambiguity here. So I like to clarify that. J not equal to I, except the major. Okay, except the major. The minor clauses, I'm going to select for them constant values such that the Ci changing the truth value of Ci, okay, the major changes the truth value of P. Now, before we understand actually changing, let me make it clear this part. Okay, so I hope everyone understood what we are saying here. So it says I have a major clause. I make it the major. Let's say B is the major. So A, B, C. I have three clauses. I nominated B to be the major clause. Maybe in the second turn I have B now. B is the major clause. So A and C are minor clauses. Okay. So what determination is saying? I'm going to select values for A and for C such that changing the truth value of B changes the truth value of B. You understood what I'm saying? Now again, so if C is the major clause, then I'm going to select values for A and B such that changing the value of C actually changes the value of P. Similarly, if A is the major clause, then I'm going to select values for B and C, minor clauses, such that changing the value of A changes the value of P. Okay. Now, a little bit of clarity that I would like to bring here. So determination in itself, I think I was mentioning it before this discussion also, like a little bit before this, that determination itself is not sufficient to change. Okay, rather it says it can change. So determination is a necessity but not sufficiency to change. I mean I understand it's slightly ambiguous at this point. Here it says, okay, the other definition about activeness uh, you know was better actually. It says if A is false, then B completely determines, in the sense that truth falsity of B influences truth falsity of B. Influences, not change. It's a capacity to change. It might change. On the other hand, as always like to think of it in the other way. I think of it like, if a clause is not determining, okay, if a clause is not determining a predicate, then it cannot change at all, regardless of its values. Okay. On the other hand, if a clause is determining a predicate, then it can change. It is not as if it will change. It can possibly change. It has a capacity to change. If it does not determine, then it cannot change at all. Okay, so that's the difference between changing and determination. Determination is a necessity, but it is not required that it will change. Okay, and this will also become clear. That's okay. So recap: I have a major clause. I'm going to select values then for my minor clauses such that my major becomes active. What is determination again? It is activeness, right? So basically what I'm doing is I'm making my major clause active. Okay, so if I were to go back to the basic example of what we did here, no, A or B, I have these two clauses. Let's say I nominate A to be the major clause. Then for B I will select a value such that A is active. How do I do that? So in this case turns out that I have to make B false. No, if I make B false, then A becomes active. If not, if A B, because if B is true, then A will not be active, right? A will not be active. So I have to make A true, rather A the active clause. So I know that I have to make B false. And how do I figure out what I need to do to my major minor clauses such that the major becomes active? That is something that we'll figure out after some time. Okay, how to make it? I mean, in this case, I'm just seeing and telling that how to make B false. But what about longer predicates and so on? How do I do that? Right. So there's a way by which we do. There's a formula actually by which you do that. That's okay. That is deterministic formula basically. The XOR method. Yeah, go on, please.
So actually, you are told that if we take A, B, and C, and if A
Mm,
is the part of is the major part, then they if we and A can affect or influence the B part. Uh,
mm.
is the C part is also get influenced, or only the B part, or all the minor part get influenced with the major part?
No, no. Okay, yeah, no. So one thing that I like to point out here. See, the influence that we are talking about, the influence that we are referring to, or the changing of value that we are talking of,
Yes,
is
sir.
about the predicate. Okay, when I say major clause is going to influence, major clause is, I mean, not talking about major clause influencing other clauses.
Yeah.
Okay, we're saying major clause influencing predicate. The thing that
Okay.
is in question is the predicate. Okay, predicate can change or not. Can it affect the predicate, not the other clauses? Okay, other clauses are independent of the major clause. That's okay. It might have some kind of a correlation, but we are not interested in that. What we are saying is, can it affect the P, the predicate, the entire thing? Okay, you understand what I'm saying?
Yes,
This
sir.
part. Yeah. If A is active, can A affect this the whole thing?
Whole thing.
If
Yeah.
B is active, can B affect the whole thing? That is the idea. Yeah. So that is what it is. Okay, fine. And yeah, so determination is fine. I think I mentioned the part about determination not being equal to changing. So I'll come to that later. Now, again, one more note here is this does not require that major clause is actually equal to B. That is also one thing. No, it might also change, but it might be an inverse relation also. No, that okay, if my major is true, then it turns out that predicate becomes false. Major is false, then predicate is true. It might happen. It might also happen. So that's okay. That's not, as long as it is determining, it has some kind of an influence. It's fine. Okay, it might as well be that something is determining but not actually changing the value of phi. Okay, so that is also something that we'll see. Okay, so the most basic thing, I think most of it I have explained. So that's the idea here. Again, active class coverage. So it says, again, two requirements are there. This is about TR. So far we discussed about activeness determination. We are talking about what is the test requirement now. Test requirements remain the same as class coverage. Okay, we are doing still clause coverage. No, what we did in clause coverage, for each clause we are going through all clauses, making every clause true ones and false ones. No, that's what we did. We go to the next clause, make true, false. Third clause, true and false. Fourth clause, true and false. That are the test requirements. In this case, active, however, only condition is that whatever clause you're checking for, whatever clause you're making true and false, CI evaluates to true and false, two cases, right? True ones and false ones. The only condition, additional condition that is there, it must be active when I am taking the pair. When I'm taking the true false pair, I should take it such that when the clause is actually active. That is the additional thing. So you see in this case, A or B, what happens? That when B is false, and we've seen that, no, when B is false, then A is active. The bold letters basically denote that whatever is active, bro. The CI is the major. CI is A, so CI is the major, and I am making major active. How I'm making A active? By making B false. So in these two rows, A is actually active, no? In these two rows, A is not active because A is false. As soon as A is false, then A does not have any say on the predicate, no? There's no influence. So I want to select pairs for A, for example. My major clause is A. Now to make sure that A is active, how do I make A active? By making B false. So these two cases B is sorry, these two cases B is false. Therefore, you have this bold later. Okay, so then what is the condition? What is the requirement? Ci, my major clause, when it is active, evaluates to true and evaluates to false. These two cases done. So active clause coverage for A is done for A. But to go to the next clause now. I go to the next clause B. How do I make B active? This is active clause coverage by making A false. In this case, for this particular predicate, by making A false. So I'm making A false. Now B is the major. A is false, so B is active also. When B is active, I'm taking true and false. Okay. So these are your TRs. And you see number 4 actually overlaps. Uh, Rather, number 2 and number 4 are same, right? So number 2 also you have false, 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 and number 4 also is false, false. So there are 3 distinct test requirements. So one is true, false, true, and false, false. So these are the 3 test requirements that you need to satisfy ACC, active class coverage, on this particular predicate. P is equal to A or B. Okay, is part clear?
Yes, sir. It's clear.
Okay, so that's what it is. And now so far we've been doing it to understand how to, you know, the how to reduce the number of test requirements, that because you remember in combinatorial we had 2 power n test requirements. So that is exponential. That is some, most of the time infeasible. We cannot do that. Now the nice thing about active class coverage, even though we have not shown a proof for this, we have not shown a proof for this, but it is given. It's correct actually. That for active class coverage you only need n plus 1 distinct test requirements. That's a drastic improvement if you ask me, right? We were doing combinatorial and it was like huge. Whereas for active class coverage you only need to do n plus 1, and still we're able to capture the effect of each clause because we are doing exercising each clause individually also, no? And we are able to capture its effect on the predicate individually in only n plus 1 test requirements, right? So that's a major improvement in that way. Okay, so that's why this determination is, is a good thing, and that's why we need to do that. Okay, all right. So MCDC is the older criterion, like the legacy, not legacy, I mean certain, uh, you know how do I put it? So certain certifications that are there, for safety critical. Let's say I talk about maybe self-driving cars or something like that. No, so you have algorithms there and so on. So some applications will require actually you to satisfy certain certifications that are there, right? So MCDC for safety critical software is also required that you do that. You do such testing on whatever software you have when you're doing safety critical software. Okay, so MCDC is basically same as active class coverage. Okay, so that's one side note that is there. Okay, so now, stemming basically from this active class coverage, there are 3 things that come out. Actually, one of them is actually the active class coverage. So active class coverage, if we say, without specifying which active class coverage, whether correlated or restricted, we just say active, then it is assumed to be general. Okay, general active class coverage and active class coverage are the same thing. This part that we discussed, no, active class coverage is the same thing as general active class coverage. Okay, when we don't say anything, it's the general active class coverage. So this is the general one. 2 more things come out of it, that is correlated and restricted. Correlated has to do with the predicate and determination again. So I'll come to that. And restricted is easy to understand also. A little bit of time will be required. And once you understand this, basically I'm covering week 6 also. So once you understand this, inactive class coverage just is kind of the complement of this. It says when you are taking those major clauses and you're taking the pairs, you must make sure that your major clause is not active. It is inactive. Hence the name inactive. Okay. All right. So GSS is the same as ASC. Again, same thing. No, for each predicate, I'm making it active. How do I make it active? Minor clauses. I'm going to choose minor clauses such that my major clause determines P. Major clause is active. Once it is active, I'm going to take the pair. What is the pair? Pair is major clause true, major clause false. Okay. And the other thing it says about this one general is that the values chosen for the minor clauses CJ do not need to be the same when C has 2 as when C. So when you're taking the pair, no, I'm talking about the pair. Okay. So you have CI, the major clause. I'm going to take the pair true and false. So GSCC does not insist, or there's no restriction as to what your minor clause is. It might as well happen that for major clause true, my minor clauses were set to some combination. some combination was there of true false values were there, constant values of true false for minor clauses there. I'm taking the true case for A, let's say. Then I select that false case for A. It might be that my minor clauses change. As long as my major clause is active, it's okay, because there can be multiple combinations of my minor clauses. It might happen in certain predicates. In general, it might happen multiple combinations for my minor clauses such that my particular clause becomes active. It might happen the same clause, no? So for A to become active, there are several possibilities, maybe several combinations that you can select so that A is active. My objective is to make A active. Okay. So what it says is general active clause coverage. It does not impose a restriction on the minor clauses. It says as long as you're making it active, it's okay. You take the true case, and as long as it is active, you're taking the false case. So that's fine. Even if the minor clauses change, in between, if it goes from true to false or false to true, as long as it is active, it's fine. I just need the two cases, true, false, for the major clause while it is active. Okay, so that's okay. This is the part about ACC or GACC. And one thing to note, this is more of a note actually that you have to keep in mind, that a general active clause coverage actually does not subsume predicate coverage. Okay, so this will not actually subsume the predicate coverage. Yeah. So for this, maybe I mean this is an example of implication actually. Maybe I'll share one another example on discourse maybe that will make it clear as to how GCC does not subsume predicate coverage. Okay, for the time being, for the lack of time, maybe you can just take it as it is for now. I'll share that on discourse later. Okay, so this was the general case. Now correlated, note at what it says. Okay, the same as general active clause coverage. It says for each predicate P and each major clause in that particular predicate, choosing the minor clauses such that CI determines P is the same thing. No, I'm making it active. Active part first of all, active. Once it is active, I have CI evaluating to true and evaluating to false. Okay. Now it says about the minor clauses also, but it is not talking about their value. It is not talking about the values of the minor clauses. What it says is that you must make your major clause active in such a way that when you flip your major clause, it must change P. Okay. That is the distinction between determination just being a necessity and not a sufficiency. Okay. I said that it might happen that something determines the predicate and it does not change its value. Okay, therefore, we need correlation. Correlation and determination are not the same. Okay, remember that always. So determination is a necessity. We have to make it active. That is active. That is not correlated. That is just the active part. Determination is active. You have to make it active. Now it might happen that it might change also, which is fine. If it is changing, it is fine. But if it is not, it might happen also in general. I'll show you an example. Maybe I'll share on Discourse also that there are cases wherein it is active. The major clause is active, but still it is not changing the value of the predicate. Okay. Therefore, earlier I said that determination is not actually changing the value of P. Okay. So what then correlated additionally says, it's an additional constraint that it is imposing on the requirement. It is saying that you make it active in such a way, your major clause, such that when you flip your major clause, your predicate must also flip. It should not remain the same. I mean, that's a requirement, test requirement that has been added. Okay. So it is the same as GSSE, but it is talking also about the predicate. That my predicate also must flip. It is not as if it is just not flipping. Okay, so for GSSE, that is not a requirement. Even if the predicate remains true in every case, I mean, of course, it will not happen, but let's say you're selecting the pairs and your predicate remains true, it can happen, right? So it's okay. GSSE is still satisfied, but CSSE will not be satisfied because it says, no, I must make the predicate also change, you know? So that is the difference. Is this part clear? It's very important to understand. Any questions on this?
No, sir, it's clear.
Okay, fine, very good. So that's what we have, and I think, yeah. So by definition, now you see what it says: the values chosen for the minor clause of CJ must cause P to be true for one value of the major clause. When my major clause is something, my predicate is something, I'm going to flip my major clause. Then the predicate's value must also flip. I mean, that is by definition. I'm saying that. That is
Yeah,
in
it's
part of
just
the test.
effect making. No? So it's just effect making that if a major clause is true, then it must affect the
Huh.
predicate.
It must affect the predicate.
Yeah,
It is not as if it can, rather
yeah,
it must. So if
exactly.
it must affect, you see, by definition, CSSC subsumes predicate coverage because you're saying that. No, that is a
Yeah,
constraint
sir.
that we are
Yeah,
putting.
sir.
It must
Yeah.
subsume in that case because
Yes,
predicate
yes, yes.
will flip. And as,
Yeah,
as as soon as it flips, the predicate flips, predicate coverage is achieved, no? Because we have to make it true once and false once.
yeah, yeah.
Okay,
Yeah,
fine.
sir.
Now we are coming back to minor clauses. Okay, here we are talking about P, no? We just said the P must flip. P must be affected. P must
Yes,
change.
sir. Yes,
Okay,
sir.
now we are coming back to minor clauses in RACC, restricted. And now remember again that this is not talking about P, even though in certain definitions you might see other places. Therefore, we say we stick to our definitions because we've been following it. So there's some lot of slight room for these things to be interpreted. And the way we have chosen is that in some places you might say the restricted active clause coverage actually subsumes correlated also, because it imposes both requirements, saying that P must flip and the minor clauses must be the same, this part. Okay, so if we impose both, then RICC actually subsumes CSCC. However, in our case, we have kept it relaxed actually. So CSCC individual is separate. CSCC just says P must be flipping, and we are not talking about the minor clauses. Minor clauses values, we are not talking about that. Minor clauses values may change, may not change, that's okay. But P must flip. In RACC, we are not talking about the predicate. Predicate might still remain the same, but the constraint is on the minor clauses. It says when I am choosing the pair, major clause true, major clause false, whatever my values were for the minor clauses when my major clause was active, rather it was true, it must remain the same when it is false. You see? So if I go back quickly, you might understand that this basically is the RACC pair. If I can go back to the A or B
Okay.
example, this part, you see? Mm, this part, you see? So what happens here? So major clause is A, assuming this part only. Okay.
Yeah.
So I have A true and A false. B remains false. You see? So this is RACC actually,
Yes,
isn't
sir.
it? And it is also GSCC, because GSCC is saying that okay, I don't care about the minor clauses. You just make it true and true ones and false
Prediction.
ones. As long as it is active, it's fine. Okay,
Yeah.
and CSCC, yeah, CSCC says this is not CSCC, however. Okay, is
It
it
does
CSCC?
not
Yeah, is
state
it?
that.
No, no, it is CSCC also. Sorry about that. Yeah, the CSCC also, because when B becomes false, now A is having the sole influence on B.
But the
No other
B
clause.
is false. If the B is false, then A is false. Then how it can affect the part
No,
of the
no.
A?
What I'm saying is when A is true and B is
Yeah.
false, what is
Yeah.
P? P is true.
Yes, sir.
When A is false, B is false. What is P? P is false.
Then P false.
So P is flipping. P is flipping between true and false. When I select true
Okay.
and false from major
Okay.
clause,
Okay. Okay.
so
So,
it is CSCC also. Yeah,
so
go on,
in
please.
RACC, predicate changing doesn't matter.
Doesn't matter. Doesn't matter.
Like it can be true in both the cases.
It can be true in both the cases. Yes.
Oh,
At least the way we have defined it in this particular course. Yes.
okay.
Okay. Right. And one more thing, one slight nuance that I'd like to just point out. If B were true, what RACC is saying is not about false though. Okay, not about the specific value. It's saying it must remain the same. If assuming that for some reason when B is true, A is active. So true is there. Now what I'm saying is that for my major clause, when I'm going to go to the next pair, next value for the pair, my minor must remain the same. So if it were true in that original case, it must be true in the other case also. Like it must remain the same. So another thing is that if I were to have another clauses like multiple other clauses that are there, C, D, E, F, and so on, whatever combination you selected, let's say it was something like false, true, false for three more clauses that are there. Okay. So this combination must remain the same when I go to false part for A. Okay. So that is the idea. It must remain constant. It must not differ between the true and false for the major. That is what RACC is saying. But all those restrictions GSCC and CSCC are not imposing. CSCC is quite simple. It just says when you are flipping the major, predicate must also change. You must ensure it changes. Okay, that's the idea. Now, one thing that I'd like to just point out before going to this inactive. So this part is okay. Yeah, I think we mentioned this. No, the value chosen from the minor clauses CJ must be the same when CI is true as when CI is false. Must not differ. Fine. Okay. So few examples here. Yeah. So you see, yeah, it's a very good example. So maybe I'll spend a little bit of time here. So let's see if I were to do, and I'm talking about one clause only, okay? Because for multiple clauses, it's difficult to talk about every clause here. So, and in the questions also, we talk about only one clause and one predicate. So let's say I'm talking about A. So my major clause is A in this case. We are doing rather active clause coverage. So we have to make it active, right? So A is my major. How do I make A active? So for that, you have to go to determination and figure out how to the formula for that, like how to determine the conditions for making something active, like how to figure that out, how to find it, right? So that we have not discussed. Maybe we'll discuss it. But in this case, it is mentioned that for A to determine P, for A to be active, B or C, this entire thing, this entire thing, this is the PA basically. So PA is this B or C. So B or C must be true. If this is happening, then A is true. Rather, A is active. Okay. So we'll assume that. So when is the case when B or C is active? Which are those rows? Here B or C is true, right? This thing is true. B or C. Because both are true, so true, of course. True, false, also B or C is true because B is true, so the entire thing is true. That's fine. False or true. These are the minor clauses, remember. Okay. False or true, again true. So these are the three cases when A is active. That part is fine. Because all three, one, two, three, all three cases A is active. We know that. Because for A to be active, B or C must be true, which is happening in the okay, GCC. How do I do that? So in fact, all three, all six cases, A is active actually. All six.
So your voice little is break little bit.
Yeah, is my voice breaking? Is that
Yes,
fine now?
it's a little bit.
Okay, okay. I hope maybe some other tabs. Okay, so I hope is it fine now?
Yes, actually it's fine, but some of the important points that you deliver, it's just break over there. So just uh,
Oh, okay, okay. I'll just recap maybe. So what I'm saying is here I'm nominating A to be the major clause. This part is okay. A is the major.
yes, sir.
Okay. So I need to make A active then because A is the major. We are doing active clause
Mm,
coverage. A I have to make active. How do I make A active? So I
mm,
said that we have not figured out how to figure out the condition for
mm.
something to determine something, the predicate. Okay. But in
So
this case, it is
actually, it would be
given.
having two
Uh,
raised to power n combinations, right? Like 2 into 3, 2 raised to
yes.
power 3, 8 here.
8 combinations. But the thing is
Yeah,
that
but for
if I were
general,
to
we
go
will
back,
come to the 6 by deterministic
yeah,
formula.
why we are not taking 4 and 8 here? Because in 4 and 8, A is not active.
Yep.
We are talking about active clause coverage, so there's no point in
Mm.
taking 4 and 8 because B or C both are false, so A is not active. PA is false, no, for 4 and 8. So we removed it. That's what I said. So basically,
Yeah, but we use that
we
formula
have to
to
have B or
determine
C
that,
as true.
right?
So exactly. You use that formula. So I'll come
Okay.
to that formula also maybe. Okay, I'll just finish this. So in all the six cases, A is active. That part is okay. Now, how do I do GACC? Can anyone tell me one GACC pair here for A? For A? GACC? What GACC says? I need to select one
1 and
case for my
5.
major clause true. Yes, true and
Yeah,
false when it is active. 1 and
Mm.
5, 1 and 6
one.
also, 1 and 7 also, 2 and 5 also, 2 and 6 also, 2 and 7 also, 3 and 5 also, 3 and 6, 3 and 7 as well. Because no other conditions are there, okay? I just need to make sure my major clause is active and I am selecting true and false pair for that, for GACC. What is the, and can you figure out RACC pair here? Any RACC, one single
Yes,
RACC pair?
1 and 5.
5?
Yeah.
Yeah. So
Or
1 and
1
5 is
and
basically
7
because it's true and
also.
false. And
1 and
hmm,
7 also.
no, by 1 and 7, why 1 and 7? 1 and 7,
Uh,
you will not be RACC, no?
oh,
RACC says,
RACC. Okay, okay. I was going
yeah,
CACC. Okay, okay.
yeah.
Yeah, yeah.
RACC
That
is
would
you
be
have to
2
make,
and
yeah,
2 and
6,
6. Yep.
3 and 7.
Yeah.
Very good. Yeah. And yeah, now CACC. CACC, I cannot select, let's say, for example, one. In fact, yes. Okay, so I can select anything. I can select 2 6 also because 2 6 is, major is true, major false at 6, and predicate is flipping. In this case, yes. So I can select that. That fine? CACC.
Yes, sir.
Okay. All right. So that's what you have. Yeah, RSC. So what we have done is we have paired it, no, based on the minor clauses value. So true case, true false case, and false true. And all these three you have that true false happening. For the major clause. So that is what you do. I hope this part is clear. Maybe I'll do an example separately also. Okay. So these were the things that we've seen in logic coverage criteria. We are just making the predicate true and false, the entire thing. Clause coverage, individual clauses we are exercising, we are making it true and false individually, but we say clause coverage, we see that clause coverage does not subsume predicate coverage, and predicate coverage actually does not exercise every clause, so that's also a problem. Combinatorial coverage is good because it does both. It does predicate coverage, it does clause coverage also, but combinatorial coverage, to do that is difficult. It is infeasible. It is not, like, it is not easy to do, right? Therefore, we wanted something else, and hence active clause coverage came in. And then these three things are there: generalized active clause, rather general active clause coverage. Correlated says P must change, predicate must change. GACC does not impose any restriction. Restricted says minor clauses must remain the same for your true false pair, for the true case for the false case for your major clause. That is what these three criteria are. And one thing that I'd like to point out before going to CIC, rather for inactive, is that there is no CICC. Okay, it does not make sense because remember we said if something is inactive, then it cannot change the value of P at all. Okay. And correlated says I want to change the value of P. So how can there be inactive, correlated, inactive class coverage? Therefore, you do not have a CICC, okay? Because it does not make sense. Uh, when it is inactive, we know it cannot change. So how do we correlate then? So therefore, we don't have it. So in ICC, inactive class coverage, only two things are there: GICC, general inactive class coverage, and restricted inactive class coverage. In general inactive class coverage, we say you have to select the pair. Again, same thing, no other restriction. Just that your clause must be inactive. So the thing is, the condition for determination, whatever it is, once you figure out with the formula and so on, when it is false, once you negate it, when you negate that condition for determination, it becomes your condition for inactiveness. It becomes your condition for not determining. So it is the same. The condition is same. When it is true, it is active. When that condition is false, it is inactive actually. So to make something inactive, you have to again figure out the condition for determination and make it false. You have to make PA false, PB false, whatever your determination clauses. Okay, that's what you do. So two cases. Okay, so you take pairs again when it is inactive, and restricted says again it has to be inactive, and I'm going to take true and false while my minor clauses remain the same. That is the idea. Sorry. Yeah, and you have four requirements then. Why? Because we are saying that P does not have any influence, like the major does not have any influence on P, right? So hence four cases are, are there. Because Ci can be true with P true, right? Because it does not have any say on P. And Ci can be false also, major clause, when P is again true. So that's okay, does not influence. And Ci is true when P is false also, that's possible. Or Ci is false when P is false. So four cases for inactive. Yeah, so the only difference between general active and inactive is that it does not determine. You have to select minor clauses such that it does not determine. The major clause does not determine the predicate. And then you cover for these four cases. Okay, that's what we have. And some motivation as to why we do that. Maybe you can go through that later as well. Okay, yeah, correlated ICC does not make sense as the major clause does not determine the predicate. When it is not active, how can it affect? So I mean, and correlation says it must affect. So both are in contradiction. We cannot have correlated inactive, right? And yeah, so GICC is the same thing. And the values chosen for minor clauses CJ may vary amongst the four cases, similar to GACC. No restriction on the minor. It's fine. And restricted says that when P is true, one case is when P is true and you are selecting the pair for your major clause, true false pair. The values that which you have chosen for your minor clauses CJs must remain the same for these two cases, 1 and 2. When P is true, P is true is one case, right? And then in that we are selecting true false. So my minor must remain the same when it is inactive. And similarly for the 3-4 case also, when P is false, my minor clauses must remain the same when CI is true and when CI is false. So this is restricted inactive. That's what you have. Yeah, so that covers for both week 5 and 6, I believe. Yeah, one more thing that is there about infeasibility is some of the pairs might be infeasible. So what we do is maybe we can ignore certain test requirements which are not possible. Maybe for example, you see all four cases might not be possible with RICC. It might be that you are only able to satisfy first two. These are the TRs, right? Only first two or three, maybe four cases are possible. or maybe three, four, any of these four, two of these four you're able to satisfy. Maybe only with the p is equal to true case or p is equal to false case, any of these cases. So then in that case, it is partially satisfied, right? It is not completely satisfied, and that's fine. We'll ignore the other part. Maybe if I'm able to satisfy only with p true, that's also fine. I'll take the so that is okay, I think. Okay, so this is again some discussion about feasibility. Okay, it's fine. All right. Anything else that is there? CSAC, we've seen it. Again, same example. Yeah, dealing with infeasibility says we can ignore infeasible test requirements. As I said, no, whatever you are able to satisfy, you only take that. And how does that infeasibility or feasibility come in? Actually, from the predicate itself, from the predicate and the condition for determination, you will know whatever is which requirements are feasible, which are infeasible. You'll come to know that from with the predicate itself. You need not have anything else to know that. Okay, the predicate itself will determine. I mean, you know, uh, yeah, the predicate itself will cause the test requirements to be either feasible or infeasible. So that's fine. Okay, and that's what we have. We'll end
So,
with this one,
so
and I'll do an example separate.
for
Go on, please. Mm.
finding this GICC and RICC,
Ah,
so we have to
ah,
do that P of A, P of B first, deterministic
ah, ah,
programming,
ah.
and of
Exactly, and then you make it false. You negate it.
and
You
we
do a
will
not
take
on that. Mm.
the false things there, not the
Ah,
true
exactly,
cases.
exactly. When PA is false, that is.
Okay, so we will take the
Ah,
false cases, and those things will
pa-
go for our
ah,
GICC.
exactly, exactly. You're correct. So you select
Okay,
pairs when it is false.
okay.
Okay, fine. And again, so this is simple enough to understand combinatorial because we said every possible combination. No? So of course it does subsume RACC, both cases fine, and correlated also. We are not having an edge between RACC and correlated. By the way, one slight, I think it's a mistake. So correlated actually subsumes general. Okay, CACC subsumes GACC. Okay, actually that's fine because GACC is relaxed. No, it just says to make it true once and for all, which is happening in CACC also. No, isn't it happening? Whatever happens in GACC is also happening in CACC. So that's fine. So therefore, CSC actually subsumes GCC. There should be an edge here. But RACC and CSCC are separate. We have not added that constraint saying that in RACC we must also make sure that the predicate must change. We are not saying that in RACC. Okay. So in our case at least, therefore we don't have an edge here. But CSCC, of course, by definition, you see it happens, right? So GSCC is the most relaxed version of the thing. Similarly, combinatorial will do RICC also for you because it is doing everything, so it does that as well. And general inactive class coverage also. And general inactive class coverage actually subsumes predicate coverage as well as so CSSC also subsumes. Why CSSC subsumes predicate coverage? Is because we said that no, we said that predicate must flip. So if we've said that, it must also subsume. So therefore, it is subsuming, and that's what the graph says. All right. So this is fine. I think I'll go over some examples of doing it. Okay, and the determination, like how do we figure that out? The conditions for determination. So for that, I'll have to annotate. So I'll maybe share another screen, and we'll do one example. Okay, fine. So I'll just stop sharing for the time being. Yeah. Meanwhile, if you have any questions, please let me know. Yeah, just give me one moment, please. I'll share an example and try to do that. We'll take it from the slide only. Okay, is the screen visible?
Yes, sir.
Okay, all right. So then we will do one example. Um, so let us take one of the examples from the slide only. Let's see what we have. Right, yeah, this one we'll take. Okay, so let's say the predicate is. All right, just give me one moment, please. Um, all right, so what we are saying is the predicate of P is this. I'm taking from the slide only. A and then another clause B or C. Okay, that's what you have. So now what I'm going to do, I'm going to say that my major clause is A. We don't need to CI, no? So CI. It is just saying that my major clause is A. That's okay. Now I say that I have to figure out the uh, conditions when, because I just said A is the major. That's okay. But I need to make A active, no? How do I select values for B and C? B and C are there too. How do I select B and C such that A is active? That's what we are saying, right? So for that, I have to figure out the conditions when A determines the predicate. So the general formula to do that is something like this. This is general formula I'm telling. Okay. We denote it with something like this. Okay. So we say P and then below that we'll write whatever that predicate is, rather clauses, whichever clause you want to make active. So let's say I'm doing for A, for example, for in this case. Okay, I'll make it smaller. Yeah. So I'll say PA. Now, the condition says that what we have to do, the formula says that I have to copy the predicate, the entire thing. So you have this predicate, no? I'm going to copy the entire thing where, so let's say I'm saying I'm denoting it P only, where A is true. Okay, so this is a copy. When I'm going to set A to true, I'll show you also. And another copy I'll make of the same predicate, which is the predicate in question. Right, when I'll set A to false. This is what I'm doing. I'm doing it with a major clause, okay? Whatever is the major clause. And why we are doing it? To figure out the conditions when that becomes active. Okay, this is like a formula. And these two things will have a XOR or XOR in between. Okay, this is how you say that. Okay, so this is the general thing. Any clause you have, you want to figure out the conditions for when that clause determines the predicate. Okay, you have to use this formula. Replace A with whatever clause you want to make like active. Okay, so you have PA in this case. So I'll copy the predicate, set A to true, and XOR the whole thing with the again the predicate copied when A is false, set to false. So I'll do that. Okay, I'm doing it here. So let's say PA is equal to, and I'm going to copy when A is true. So I'll set A to true. This is like a constant I'm setting. Rest of the things will remain the same. Okay, true and BRC, and then I have XOR, right? This XOR, and then I'm going to copy again A, rather not A, sorry. This will
False.
be false. Yes, thanks. Um, this will be false, and B or C remains the same because I'm just copying the thing and setting true and false two cases for my major clause, whatever it is, and the rest of the things are basically copied. So I'll copy it. Now I'm going to do simplification. Okay, this is the important thing to understand. How do we do simplification? So before moving ahead with this solution, I'll describe a little bit of the things with a separate thing that I'll describe. Okay, so let's say I'm having this thing A and any for any clause, yeah, A and true. A and true
A.
basically A, true goes away and case. Okay, A and false
False.
is false. Just give me one second. Okay, and this because anything and false is false regardless of whatever it is. The other case is when A or true is there.
True.
This will go to true because anything becomes true in or, the whole thing becomes true. And last case is that of A or false. So when that happens, the
A.
false thing will go away, A remains. Very good. So this is what happens. Okay, so this is the thing. And the other thing is about De Morgan's law. So you might know that from the set theory as well. So what happens in this case is that let's say I have a or b, right? Then I'm doing a not before that on the thing. Then what happens is that it becomes, the not is basically a spreading. So the not will get distributed. So it will become not a, right, and not b, not b. Not is spreading, and the and will become an or, rather or will become an and. So that's what De Morgan's law says. Okay, so this is basically equivalent. These two things are equivalent to each other. This part and this part is actually equivalent. Okay, so not A or B is actually not A and not B. Okay, that's what you have. And
Yes.
similarly, so that's what you do. You spread the not and flip the flip the sign
Mm.
in between. So if it is a disjunction, it becomes a conjunction. If it is a conjunction, it becomes a disjunction also. And similarly, I'll do that again. So in this case, let's say I have a not A and B. Okay, that's what you have. So again, I'm going to spread the not. So it becomes not A or not B. That's what De Morgan's law says. Okay, so these two things are equivalent to each other. So you have to remember this. Now again, so if again, so some things might happen. So what happens now is that if I have not A or not B, and I'm doing a not on that, so then the not gets a spread, right? So it will become not A and not B. The thing with not is that two knots will get cancelled. Okay, because not of not is I've not done anything, right? So it remains the same. So it just becomes A and B. Okay, so not of not A or not B is basically A and B. So some simplifications rule you must know. So this De Morgan's law and this part about A and true being A and false being false. A or false, A or true is true, and A or false is A. So with this in mind, we'll go forward and try to solve this. In fact, I should have removed this. Okay, let me see if I can move it around. Okay, not getting the option here. All right, so we'll do it here anyway. So now we know the simplification, right? So how do we do that then? In that case, I'll make it smaller, maybe. Yeah. Okay. I hope it is visible enough. Like it is large enough to be visible. Is that okay?
Yes, sir.
Okay. Okay. So then I'll continue from here. The black uh, part. So I have PA. Right. So we see
B or
true.
C.
True. When and is there, true goes away. So it will be B or C. Very good. B or C, and XOR
XOR
remains. Uh,
false.
and yeah, so because false and anything goes away, you don't have to look even. So this becomes false, right? And one thing that I'll also point out is about the XOR. So this XOR
B
symbol,
or
what
C.
happens? So that part I'll mention about the XOR table. So what happens with XOR is if you have something like A XOR B, the truth table goes something like this. Okay, so B A XOR B. What happens is that you can have true true, true false, false true, and false false. These are the first four cases. Right. So if both are true in the XOR exclusive OR, then A XOR B will turn out to be false. If both are different, then it is true. Both are different, it is true. If both are false, also it is false. Okay. So what it is saying is both should not be the same. If both are true, also both operands are true, then the XOR results in a false. Right. So whether it be true, true or false, false, it will be false. If only it is different, then the XOR becomes true. So when I'm going to, I want to make this PA true, right? If assuming that I want to make the PA true or simplify it. So I see false is on one side already. The side is a false, right? This part is already a false. So I need to make this part true so that this is true, right? So I'm only so this false goes away basically. This false goes away. So your PA then, okay, I'll use some different color maybe. Have a darker color here. Um, right. So your PA then, I'll remove this part. Okay. So your PA then just becomes B or C. That's what you have. Now, assume, I mean, for an example, we don't have it here in this case, but it might happen that some clause is there and then, sorry, it's a different example, maybe make it X. Okay. It turns out that you have a B or C, XOR true. So what I said, this is already true. If I want to make the whole thing true, this is already true. So this must be false, right? This must be false. So then what we do is that we negate it. I mean, we need to make this false. So we negate it. So we negate it, not B or C. And then we are going to use De Morgan's to expand it. So we say not B and not C. So then PA is your not B and not C. This is how you do it. Okay. So once you figure out what you need to do, appropriately you select the conditions and either negate it depending on if you want to make it false, then you negate it. If you want to make it true, I mean, depending on what the XOR is, the operands of for the XOR is. Once you have it, then you know the conditions. So in our case, for this one, it's predicate A and B or C. Sorry, PA is basically B or C. This part, and that's why it says in the slide also. This must be true for the clause to become active. Now, for the inactive case, so this was the active case, right? If PA is true, then what happens? A is active. Determination is saying whether something is active or not. If I want to make something inactive, then I have to do the negation of that. I want to make it false. So how do I want to make it false? So I can make it false by setting any one of these things to false, right? Any assume that PA I want to make false. So then I can set any of these things to false. In fact, I can negate it like this. And yeah, if I want to make it false, then it is not B and not C. Okay, yeah, I was actually wrong. Not any one of these. I have to make both of these to be false to it because this is OR, right? So to make the entire thing false, you have to make both of them false. Okay, that's the benefit of using the laws. So you have not B or C. It gives us not B and not C. So I have to set both to false if I want to make A, the predicate A, inactive in this case. If I want to make it inactive, then I have to set B to false, C to false. Okay, if I want to make it active, then I have to set either B to true or either C to true. This entire thing should be true. This part. If I want to make this active, then this part has to be true. That's what happens. Okay, so you have both cases. And once you have the conditions, no, then you know what to do with them. Like you know how to select the pairs. So you accordingly you select. Okay, is part clear? Any more
Yes,
questions?
sir, it's clear. Yes.
All right, all right. So yeah, that's all there is to it. Okay, with this maybe I'll stop sharing the screen. Okay. All right. Yeah. Any other thing that you'd like to discuss, or shall we close?
No, sir. And sir, your teaching skills are so good.
Yeah. Thank you
Okay.
so much. Really appreciate it. Yeah.
Yeah, it's
So
really
this was recorded also. I hope other people can
okay. Yes.
also take benefit. Because lots of questions came in, in particular with determination. Because primarily because they tend to confuse between changing of the value of the predicate and determination. That is correlation and determination. So it is. I mean, it happens. We assume generally that determination means changing. However, it does not. Okay. Determination is a necessary condition again to close with it, and basically you have to do that first, and then whether or not it changes depends on the predicate actually. So I'll share one example on discourse wherein you can see that. You can see the difference wherein CSCC is required. It is like you are having a determination, your determination is true, but it is not actually flipping the predicate. So that is, we have one example uh,
Okay,
that
sir.
I can share. Yeah.
Okay, thank you,
Yeah.
sir.
Thank you so much, really
It's a
appreciate it.
pleasure to have
Thank
you,
you.
sir.
Thank you.
Thank you, sir.
Bye.
Okay.
All right, I'll stop sharing.